My name is Mengshoel, and I'm on the faculty here at Carnegie Mellon, Silicon Valley.
My name is Priya. I'm a Ph.D. student in Silicon Valley. Currently, we are using a real-time network. It is an electrical power network that is used for a aerospace vehicle. So we are trying to help a network analyst to understand and debug the network. In particular, if there is any fault in the end user component, we help the network analyst to identify the particular component that is responsible for this failure. So using our multifocus technique, the network analyst can at the same time explore and analyze different components in the circuit and study their time series graphs and spot out the exact component that induced the failure.
I think what is interesting with this research is that we are focusing on visualizing large networks, and we're interested in things that might happen in those networks that are not easy to see just by using very simple zoom and pan techniques. So, for instance, there might be something going on in the electrical power grid on the East Coast that might affect a transformer or a business in the Midwest, and we're interested in how those faults or strange behaviors interact and in different parts of the power grid and in other types of complex networks.
Now I'm going to show you an example scenario. So let's come to this data view panel. Now let us select some interesting nodes. So here the node E181 shows a drop-in reading at time 12:50. So let me select this node. So these nodes are automatically selected in the network view. This node sensor ESH160A again shows a drop-in reading at the same time. So let us select all the nodes that shows a drop-in reading at the same time. Let's go back to the network view. As you can see, these nodes are already automatically selected and the partitions are done. So let's zoom in these nodes and study them in more detail. Okay, now these nodes, the labels of these nodes are now readable. Let us open the time series graphs to understand what is going on. So as you can see, the nodes, the time series graphs around the circuit breaker CB180 is showing a drop-in reading at the same time. So this ensures that the circuit breaker might be a faulty component. Again, we are noticing there's a sensor here showing a drop-in reading at the same time. Let's look into it in more detail. Let me open this E142 sensor, which doesn't show a drop-in reading. And let me open this one, E161. So even this doesn't show a drop-in reading. So this suggests that the sensor here itself is faulty. So we have identified two different faulty components here. One is the circuit breaker, the other one is a sensor.
We have also, even though we have focused on electrical power networks and developing both visualization for the power network itself as well as system health management and in particular diagnostic capabilities for those electrical power networks, we have also visualized some other networks and in particular social networks. We have some interesting visualizations for Twitter data, and we have also visualized other types of social networks. And the technique also works very well in that area. However, we haven't really been focusing as much on that so far, but it could be an interesting area for future research.